All right, so I think we'll get started now. Thank you for coming, everybody. I just arrived yesterday, so forgive me if I start falling asleep in the middle of the talk, but I'll try to stay awake. So we thought, Brian and I had a bit of a chat earlier in the year, and we thought we'd put in a proposal for this symposium to talk about current molecular approaches for tracking the origin and spread of malaria infections. And this is really because there's been an explosion of these types of studies in the last sort of 5 years or so, and everybody's using different methods and we're all working in different regions. So we thought it would be useful to have an overview of some of the different approaches that are being used in different areas of the world. So we have a bit of a structure for this session. We've got an hour and 45 minutes, so my introduction's going to be just a few minutes, probably not 10 minutes. The presentations and questions will then be 20 minutes each, so each speaker will have around a 15-minute talk and then time for questions. And then at the end, we'd like to have a discussion with the audience participating in that and providing your own or sharing your own experiences and questions with us. So the goals of the session are to bring together people working in the field of molecular approaches to tracking malaria, to share their insights with each other and the wider community, to identify others in our community interested in conducting these studies or already working in this area. So please let yourself be known. And we also wanted to discuss the potential of a universal approach in addition to specialised local approaches designed specifically to target certain populations. And also to discuss whether it's even possible to develop an agreed minimum set of markers for combining different data sets. So these are all things that I'd like you to think about as we go through the talks. So some of the things we need to think about when we're choosing our markers for our research studies are population structure, and spatial and temporal scale. So with regards to population structure, with declining transmission, diversity generally decreases and population structure increases, though this isn't so well defined for vivax. And also as we reach very low transmission levels, we see an increase of imported infections, and so diversity then potentially could increase after that point. So we'd have sort of more diverse parasites circulating in the population. So the population structure can also determine the number and the type of markers needed to track individual infections and assign origins. So we're going to hear a bit about that today. And also, what do we do with clonal or inbred populations at very low transmission levels, and how might we track individual infections when we have such similar parasites? And also, one thing we have to think about is the discrimination capacity of markers that have been defined from a local parasite population. So say I'm going to be talking about defining local SNPs from Papua New Guinea and comparing that to the discrimination capacity of globally defined markers. And then when we're thinking about spatial and temporal scale, there's really going to be a trade-off. And the trade-offs between the spatial scale and the number or diversity of the markers that we use. There's different types of markers. They provide different spatial and temporal scales. Microsatellites evolve much more rapidly than SNPs, for example, and mitochondrial DNA gives you sort of a temporal scale in the thousands of years. So more ancient patterns of infection spread. With microsatellites, there's a very nice review by Patrick Sutton in 2014 demonstrating how the high diversity of microsatellites can really impact your results, where we have balanced patterns versus compounded patterns of diversity in those markers. And also markers under selection, such as drug resistance genes. How do we actually look at the spread of drug resistance? What's the origin of a particular resistance haplotype that's popped up in a particular geographic area? Recombination and linkage disequilibrium can also impact what markers you choose. And also the type of analysis is really important as well. There's lots of different statistics that we can use to measure diversity and distance and also population structure. So in the talks, we're going to hear from 4 speakers, including myself, and I'll be talking about SNPs and how we've used SNPs to discriminate between parasite populations in Papua New Guinea, in the Oceania region. Brian will be talking about tracking the local and regional spread of P. falciparum in low transmission settings of Africa. Shannon will talk about the spatial and temporal diversity of Plasmodium falciparum in Southeast Asia, and looking at using some novel methods to look at parasite migration. And Ananias will be talking about Latin America and using population genetics to inform molecular epidemiology.